transformation?
Right.
Okay. Right. Map operation transformation. Okay, I'll put all of you on mute. If you have any question, please unmute yourself and go ahead. Or you can ping me on the chat as we generally practice.
Muted.
Alright, so the map operation transformation, if you look at the description, it converts below opcodes like insert to update or update to insert, insert to delete or anything. A conversion between the opcodes is possible with the help of the map operation. So why do we need something like an opcode? So why do we need something like an opcode in our general day-to-day data life? For example, you have an employee table, and for example, let us take the list of vendors table. Okay, so yeah, I think good. Rishabh is also here. Rishabh, I'm trying to recall about the map operation. So I think even you wanted to know about that. So let us do a quick recall on this map operation. So map operation, it allows you to do a conversion between the opcodes. And why do we need something like this, a conversion between the opcodes? So in general scenarios, like you have the list of materials or the list of vendors in your company, and you have to do a deduplication process, right? So sometimes the vendor A, who is supplying you the raw material, so he stopped that business and he became another vendor where he do some labeling sort of thing. Okay, so there is a change in the vendor nature. So this vendor who used to supply the raw material for you is now has become the labeling vendor. And the materials, so for example, you used to sell some ABCD products, and after some time you are not selling anymore the product D. So you have to remove that particular product from your master. We need to do a deduplication process or an upgradation process on the standard master table. So that is the reason why we have to do a map operation transformation, so that the data which we are sending from the source table, okay, for example, this is your source table and this is your target table, and let us take the first record, which is customer number 1000, is upgraded in the table. It is not present. So let us take it is not present. So customer 1000 will be directly inserted to the target table if the opcode between these is normal to insert. Okay, and
Your screen is not visible actually. It's not moving.
I'm in the notepad, paintbrush.
No, I'm seeing only the job screen, like data. This is designer.
Yeah, I think the refresh rate is a little slow. I think just is this the same with the remaining?
Yeah, it is also saying same.
Okay. All right. So let me stop showing my screen. And again. Rashid, we are going through the same process. How do we do that with the map operation? We are going to the same process. And let me explain that to you. Now you guys can see the MS Paint on the screen.
Not really. It's obstructed.
What happened to this? All
Now I
right.
can see
Yeah.
paint
We
brush.
are in the paint screen. Okay. Okay. Yeah. 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 All right. So, all right. Sounds good. Yeah, we are in the paint screen now. So we have a question from Rishabh. How are we going to accomplish these sort of activities if your target table is a permanent table? And generally, the nature of a permanent table is whenever you run a job, so what are the new records that are present in the source table will be appended to the target table. Means even though those records are there in the target table, it will be added as a duplicate data set into the target table. But we don't want to duplicate the data. We want to maintain the quality of the data by ensuring that if the record is not present in the target table, it has to be pushed. If the record is modified in the target table, then it has to be updated. If uh, the record is present in the target table which is not part of your source table, then it has to be deleted, and insert, update, and delete. So these three operations has to be done onto the target table. So the general scenario, yesterday I was showing this with the different tables, different target tables, but generally how it goes is we will have one permanent table. Okay, I make it as import, and this is my permanent table. And generally the nature of a permanent table is you can only append the data to the permanent table. You cannot update or you cannot delete the data from a permanent table. So because of these map operations, what it does is it sends the data set to the target table along with an opcode on top of that. So here the opcode is insert. So what it does is it updates, it's an update, so it updates the data into the target table. So it checks for the same record, like if the customer number 1000 is present or not, if the order number 1000 is present or not in the target table, and if the same record is present, it tries to update the changed values from the source. So now we are trying to do a change data captures. Okay, so it converts it.
How
Yeah.
it checks here? Actually, is there will give
See,
any condition over there, or like it will check automatically by using the map
it checks
operation?
automatically now. It checks automatically now, but later going down with the transformations, integrated transformation, we have separate transformations to do the table comparisons. Okay, so a separate transformation which can do a comparison between the source table and the target table, and also it lets out the uh, data sets output as flagged with insert, update, and delete. So there are different transformations. As of now, what this will do is the map operation. This map operation, it directly compares the source data with the target data. I mean, see, this is how it works. It tries to push this record into the target table, and it will try to compare if the same record is present or not. If it is present, it will stop from pushing because the record is already there. And if it has an opcode as insert, so even though if the record is there, it will again try to insert the same record into the target table. So if the record is coming as a delete opcode, what it will do is it will try to delete the same record from the target table. So based on the opcode, so when we executed this job in the debug mode, so we have seen the opcodes running on the data. So now you can identify what opcode is there. So based on that opcode, I, D, or U, so this job, so based on the opcode here, you have an U opcode. On the second table, you have an I opcode. So based on these opcodes, if it is an insert or a delete or an update, so based on these characters, opcodes, the data is pushed into the target table, and the data in the target table is modified. So if it is a change in the record, like employee number 1000, J, his role was a senior migration consultant, now he has become a lead. So what will happen, this particular designation of J will be updated in the target table rather than pushing a new record. And this is done automatically by the map operation. Got it? Any more questions on map operation? Guys, any more questions on the map operation? Because, yeah, can we do, can we modify a column value through map operation, or is that a different way of to do that? Rishabh, I did not get your column value. Do anyways with the query transformation, right? So here the shift wire as per your question. So let me stop the debug mode here. Okay, so now this is, see, the map operation is just to push whatever the data that is coming from the source with the opcodes, insert, update or delete. But if in the case what you are asking, if the shift wire region is 3, you have to change it to 4, then you have to write a decode statement that okay, if the shift wire is equal to 3, make it as 4, else get the shift wire directly from the source. So this is a simple decode statement that you can write. So what it does is it checks for the value shift wire is equal to 3, and if it whenever it finds the value 3, it converts that into 4. If not, it gets the value as it is from the source 1 and 2. Okay, is that clear, Rishabh? Alright, so perfect. So the main intention, what we are trying to do here is using the map operation. What this map operation does is it takes the data sets from the source table with a specific opcode, either it is an insert, update or delete, and it tries to push the same data onto the target table with the specified opcode as insert, update or delete. Okay, so it tries to, you know, compare the source table with the target table and see if, yeah, this record is an insert record. So I have to insert even though it is present in the target table. This is a delete record. So I have to search the entire target table and delete this particular record from the target table. And if this is an update, so I have to update these many columns with a specific value on this one. So this is how the map operation works. Okay, so similarly we have another transformation. Yeah, go ahead.
Here, so normal insert means is a brand new record.
Yeah, normal insert is just like you use a query transformation and push the data into the target table. The data that is coming from you know, the source is directly pushed into the target table. So similarly, insert means the record, whichever is coming from the source, is pushed into the target table. It is inserted. So you write a statement, right? Insert into the table, table name,
right?
Update table, table name, delete table, table name. The same SQL queries. Okay.
Okay. Yeah, I think I need to work out on this little bit.
All right, Jay. I think
yeah.
see, there are simple operation codes that you write on a SQL database: insert into table, update into table, delete into table. You can achieve those things using these map operation transformations, because generally, if you use a query transformation, it is like push the entire data into the target table. You cannot do a selective deletion. For example, you want to do a selective deletion for where the shift wire is equal to 3. So how can you do that? So you can select, extract the data from the source table, but how can you delete that in the target table? So here what we will do is we will write a query statement where the shift wire is equal to 1, 2 or 3 based on the requirement, and then go back. So now the output of this query transformation is the shift wire, which is equal to 1. Now you want to delete this selective data.
Right.
So what you will do is you will do a normal to delete conversion, right? So you are doing a normal to delete. So the output of a query transformation is R1, always a normal data. You are trying to do a normal to delete conversion here. So the output of this map operation is delete. So what it will do, it will go to the target table, check this shift wire is equal to 1, and it will try to delete those records from the target table.
Mm-hmm.
You try to do this exercise on your system with not so many transformations. This is just to demonstrate. Try to use only one single transformation. Try to first put everything as discard and normal to normal and put the load into the target table. Then take shift via is equal to 1 or any data, I mean any particular filter condition, and on top of that do normal to update or normal to delete. You just play around with the options here and you can easily do this. I think you guys should practice this once, then you can understand how it goes, because this is a very simplest transformation. Okay, so is this clear? Shall we go ahead with the remaining things?
Yeah, go ahead.
Yeah, and Rishabh, for your questions that you have asked, you have to either execute the job, then a debug mode to see those insert, update, and delete opcodes on the data, or the thing is that you have to ensure that you have properly used them within the job. So if you do not do any conversions here, if everything is normal to normal and everything is discarded, then also it will not show you the opcodes on the data. So similarly, on the same descriptions, let us go and do look at the one more transformation, map Cdc operation, which is exactly same as the map operation. So we have a question. All right, perfect. No question. That's an answer. Right. So we will look at the map Cdc operation, which is exactly same as the map operation, but it has a special intelligence concept where it can calculate the change data captured values. Okay, now this map CDC data using the required input columns. Okay, so there are two extra columns that are required for this map CDC operation. So before I go into this map CDC operation, I would like to tell you, on some databases like Oracle and I think Oracle is possible and DB2 as well, there is a possibility where you can have the CDC tables saved on the database, the change data capture tables saved on the database, and these tables will be saved with an extra column. All right, so let me show it to you. Okay, now this is how it works. Okay, so you'll have the columns. Suppose this is the table: serial number, name, type, and some XYZ. So let us assume this is a table. So now you have one, name as Rakesh, type. Just give me a second. Can we close the doors? Just give me a second. There's a lot of crowd blabbering outside. I'll close the windows and come back. Okay, I'm back. So this is generally the sort of table data that we have. You have the column name, the data in that. So type is like, let me get this, DMC and type. So this is a table where you have some data. So this is a normal table. But what is the map CDC table? What is the change data capture table? So on a database level, you will be given an extra provision with an extra column which will have this CDC type, and it will have the opcode saved on the data. Okay, so these tables will look like this. Okay, you have these these types of tables saved on the database, for example on the Oracle or DB2. So you have an extra column which has insert, update or delete opcodes on them. So what the database will understand, like this particular record, okay, with an opcode I is to be inserted into the target table. This particular record with an opcode U is to be updated into the target table, and this particular record, so wherever you find blanks, so that particular record with the blanks has to be deleted from the target table. So this is how they are saved. The CDC tables are saved on the database, and you have to read these tables and from the database. And if you are trying to read these tables from the database, then you can use the map CDC operation, which has an extra column, okay, extra column which can address these values. Okay, now let me create a job underscore map CDC. Okay. Alright, so here is this one for this one. So it has two extra columns. So if you look at this one, DI sequence number is a column on which we create the sequence number, and the second one is DI operation type. So this is the second column, which is DI operation type. So this particular DI operation type, what it does is it tries to identify if it is an insert or if it is an update or if it is a delete on the target table. So let us try to do this the same way, df underscore map underscore CDC. So now we need two extra columns to perform this operation. So first let me take the table here, make it as source, and then go to the transformations and make this one map CDC and try to connect this. And if you open this one on the schema out, okay, so here at the bottom map CDC operation tab, you require two columns. One is the sequencing column and the second one is a row operation column. So let me go back. So if you use the proper naming convention as that we have seen in this document, okay, DI row operation type or DI sequence number, so the system will do an automatical mapping. So for example, let me just copy this one, DI operation type. Okay, so let me add a query transformation because we need two extra columns than what we have from the source to perform this transformation. So select all these transformations from your schema in, drag and so select all the transformations from your schema in, drag and drop them to the schema out. Now create a new output column, insert above, give this operation type, it is of varchar length 1, and the second one is new output column, DI underscore sequence number. It is an integer because we are trying to generate a sequence number. So why do we need something like a sequence number for this? So before you do an opcode onto the, before you push an opcode onto the target table, you need to sort your data. So this DI sequence number will allow you to sort the data on a particular column. So this now it sorts on the sequence number because we are trying to populate that with generate row number function. So what it does, it generates a row number for each and every column, and when the data is going with an opcode to the output table, this one, what it does, it sorts the data and it gives the data to the output. So that is one mandatory reason. And the second one is the operation type. So let me put it as I for now. Let me take it as an insert. So now connect this with this table, map CDC operations. Okay, so automatically if you see, the sequence number and the operation type are automatically mapped because they have the same naming convention. So you can also give like something like SEQNO or OPRTYP, but you have to do a manual mapping here. So remember that if you give the same naming conventions, it will be mapped automatically. And if you are using your own naming convention, then probably you have to do a mapping here. Then on top of that, we have sort input already sorted by the sequence number. So if you want to do an extra sort, because we are giving a sequence number here, this one, and it is already sorted, so you check this box. On top of that, if you want to do a sort by ship via or something, you can select them, drag and drop them into the additional grouping column, which will do a sort on this data. So first group 1 will happen, then group 2 will happen, and group 3 will happen. So this is how you can do an extra sorting, but there should be one or the other column on which the sorting is happening. So that is the reason we created an extra column, which is sequence number, and sorted the data on top of that. Now this is what we do. On the map tab, we do a mapping and check this box. Input is already sorted by the sequence number. Now let me create a table and call this table as map_CDC, because we are trying to demonstrate the change data capture features. Now if you see here, the operation type is I, means all the records that are coming from the source. Okay, if you look at the example that I have set here, so this I is not coming from the data. I'm trying to decode that within the job. So what are the records that are flowing in from the source has the opcode as I. Okay, this is the default column value that I am giving here. So now all these records are to be inserted into the target table. So now let us execute this one. Oops, we have an error. Please check the spelling and usage. If a variable $, it must be. Alright, so that's the mistake. Go here and put this in the single quotes, because I said it is an integer and I haven't mentioned that in this one. I mean, I said it is an varchar and I haven't mentioned that in the quotes, single quotes. Alright, so your job is completed now, and you see all these records are inserted into the target table. 830 records, what are the records that are coming from the source, are now inserted into the target table. So now let me make this table as a permanent table. So now this table at the time of execution will not be dropped and recreated. Only the temporary table or the template table will be dropped and recreated, but the permanent table, the table remains same. Only option that you can do is delete data before loading if you want to delete a fresh set of information onto the target table. We have a question. Which table, Rishabh? Yeah, this is the target table. I mean, you want it to open this one. Okay. You have the entire 830 records coming from the source because it is a normal insert. Okay, now let me do the thing which will give you an understanding on this. Now, I'm not doing anything. I'm just changing this to delete. Again, I'm just changing the opcode to delete. So what it should do, as per the theory, it should go to the target table based on the opcode. With the help of the map Cdc operation, it should delete the entire data on the target table. So let us execute and see if it works. Okay, job is executed successfully. Now go to the target table and see you have 0 records. This is working because I just changed the opcode here from insert to delete. Now you can again convert it back to insert. I'm not doing any changes in the code. I'm just changing the opcode, and this now you can notice how this opcode is pushing the information onto the target table. So based on the opcode, you again go and see this target table refresh. You have 830 records. Okay, now you want to do a selective deletion. So what you can see is go to the where and say ship where is equal to 1 and execute the job. So all the data that is related, okay, let me change the opcode as well. Okay. So what it should do, it should go with a selective deletion on the target table. Sorry. So you don't have the ship via 1 here. So it did a selective deletion on the target table. So now I filter this and I'll try to see if this is equal to 1 because we did a selective deletion here. I refresh, there are no records on the target table. So see, you are trying to create a code which is very common. You do not change the nature of the design or something, but just changing one column value, you will either insert or update or delete the data based on the business logic that you are trying to give. Okay, so this is how you can use the map operations, because they push the data with whatever the opcode that you have coming in from the source or that you are specifying here onto the target table to do an insert, update or delete. So I think this is good enough, clear? Are there any questions? Am I teaching you good or bad? Alright guys, please respond if it is unclear or not so that we can go ahead and look at the remaining transformations. Jai, Gopal, Vaishali.
I think
Jai still it is think.
yeah, actually we can delete this thing like in the where condition without map CDC, right?
But you cannot delete that on a permanent table, right? Permanent table, either you can insert or delete the entire data.
I think we
right?
can use that on the previous transformation.
Map operation. Yeah.
Yeah.
Map operation is like you do a conversion between the opcodes. Okay, but you do not obey what are the opcodes that are coming from the source. So if the table is a CDC table and the opcodes are coming in from the source, you use this map operation because the source itself is defining that this particular column has an insert, this particular column has a delete, and this particular column has an update. So this is directly coming from the source. You don't have a control on the opcode. And here, if you look at this, the second set of transformation, the first one that we have seen, it gives you a control on the operation, like you can do a conversion between the opcodes. Probably, Jay, I think you should start working on that, and that will clarify your doubts. So once you start working on this, then definitely it will clarify your doubts.
Yeah, I think so. But
just do a practice on your system. Alright, good guys. Let us go ahead with the remaining transformations. So that is the reason why I postponed this in the platform transformation, deleted the last, so that we can look it together with the map operations CDC, because both of them work on the same formula. And I think we have seen this data transfer, date generation. We will see the remaining transformations as well. So effective date transformation, hierarchy flattening, history preserving, and pivot and reverse pivot and XML pipeline. And also we will see, because today, sorry I forgot to inform you, guys let me know if you have any prior appointments, but I am trying to stretch today's class a little because I was not able to take yesterday. So that we will not miss the schedule. And we will see the base match transformation. Okay, so this is one of the quality transformations which we can use at free of cost. So for the remaining transformations, we need to purchase the address directories from SAP. But I'm not an organization so that I can buy. I'm an individual trainer, so I cannot buy these things from SAP. So just in case if you have an access, so I will try to share some material with you guys and you can just read that and practice that on the system. But now it is not a quality this thing, it is completely a data integrator and data services part. So we look at these things. So now let us go and look at the remaining transformations like effective date transformation. So why do we need something like an effective date transformation? So for example, the simplest example that we can use is the price of petrol is going to increase from 28th February 2013. So we have an effective to column which will have a value changed. So effective date is like effective from 2013 28th February, the petrol price will increase like $10 per gallon or $2 per gallon. So there is a change in the value, and you are still trying to, save the old record as well as the new record. So the old record will be with the old date, so which has before 28th Feb 2013, and the new record will be saved with the new date, right, after 28th Feb 2013. So this is an effective date column that you might require when you are working with the change data captures. Okay, this is, I did not use this anywhere within my total experience, but it can be useful. Okay, so create a job, then create a data flow, df underscore effective date, EDT, or yeah, effective date. Now select this effective date transformation, drag and drop it. It is an intermediate transformation. So let us select some table and make it as your source. Then connect it with the transformation. Now if you see, it has schema in, schema out. The structure of schema in is same as the structure of schema out, but you have one extra column which is effective to column. So what it does, this effective to column, the date until which the record is not effective is automatically generated by the effective date transformation. So what it will do is, the date until which the record is not changed means that until 28th of February, this particular value of petrol price is not getting increased. But after that, this particular price will be increased by $1 or $2. So these kind of changes is captured by this column. So this particular column, effective to column, will have the date that you specify. So if you look at this one, effective to column, it has the values. So effective date column will have a date column that is coming in from your source. So this has to be mapped because that is the date column that is coming in from your source, and the sequence column will say which column will get affected. For example, let us take, we don't have the price, this one here. Okay, I'm just taking it as right here, and this effective to column will be the new column that will be created, and default effective to date is 28th Feb 2013. So go to the calendar. Okay, so I give it as 2013 and this as 02. Okay, I'm selecting this one, 28. Okay, that is 28. Okay, that is. So I'm selecting this date, 28th Feb 2013. Okay, what it does is, we can select the dates from here as well. So what it does is, that will be the default value where the value of the freight will not be changed. So after this particular date, the value of the freight will be changed, and if there is a change in the value, all the new values will be calculated as the new records, or all the new values will be entered as the new records into the target table. So this is a provision where we are creating an extra column to the target table, which will give availability that, once the values change after 28, those will be, rather than updating that into the target table, that will be added as a new record into the target table. So this map operation is all about, this integrated transformations is all about how you change, or how you save the CDCs, right? So now you have an extra column here, effective date column, and this will be the default date. And if there is any change in the value on the freight after this particular date, okay, so this is the freight. So if there is any change in the freight after this date, so what it will do, the system will save that as a new record rather than updating the same value onto the target table. So we are trying to save the old data as well as the good data. So if you look at the change data captures, there are 3 types of changes: type 1, type 2, and type. Hello? Okay, right. So Gopal, you can hear? Yeah, right. Good. Sorry that because maid was cleaning and she just pulled off the wire. She was very curious on pulling the wire which is connected to the internet, so lost the connection. All right, sorry for that. Okay, good. Now this is how this effective date transformation works. So it creates an extra provision column which will capture the new records, and rather than, if there is a change in the data, rather than deleting that record or updating that record from the target table, it is added as a new record. So you preserve the history of the old data, right, with this extra date column. So this will be the reference column on which the new record is added. So similarly, we have another transformations like history preserving. So this is actual history preserving. How do you preserve the history of the data? So in this exercise, we will look at the combination of transformations, like we'll use history generation, we'll use key generation, history preserving, key generation, then we will use the table comparison, also we will use the query transformation. So we will be using 4 different transformations as a combination in one data flow to perform the history preserving task. Okay, so now just keep your minds a little relaxed because this is a scenario on which we will be working, and this is almost one thing that I have day-to-day activities in my job. So this is one most important task. Okay, this is one that can happen to you in a real life as well. So, for example, we are dealing with the data, and we have some information. Like I'll just put it in a very layman examples, and later we can recollect or correlate this with the real-time scenarios once you start working on the projects. So, for example, I have a customer. For example, let me take myself. I'm a customer of Shopper Stop, and I'm from Hyderabad. I was there doing the business with Hyderabad Shopper Stop branch for more than 10 years, and all of a sudden I got migrated to some Delhi or Bangalore. Well, let us take Bangalore. So I got moved from Hyderabad to Bangalore, and still I can use the same Shopper Stop card, that is because it is valid across the India. So I'm using the same Shopper Stop card, and I'm going to Bangalore Shopper Stop, and I'm trying to swipe the card. So now the machine identifies that this card has an address of Hyderabad, and if they do a commit statement or if they do an update statement, all my 15 years of history with the Shopper Stop will be overwritten with the new address. I don't want that to happen. I want my history to be saved as well as my future. So I want both the records, all my old transactions and also my new transactions. I want both of them to be saved. So how do I do that? So I have to save the old record, and I save the new record as well. So using the history preserving transformation, I can save the old data and I can also save the new record. So how do we then identify the difference? There will be an extra flag column called column flag, which will either set the old record to Y or the new record to N, or it will do a vice versa. It will set the new record to N and old record to Y. And also with the help of the key generation transformation. So if, for example, your source is having 100 records and you already moved the 100 records into the target table. Now, from the source, the first one, the customer number ALFKI, the city is updated from Bangalore to Chennai. So what will happen? This particular ALFKI, generally if you normally execute a job, it should be either updating or overwriting the target table. But now this key generation, it generates a new key as 101, because keeping in mind you have 100 records in your source table. This new record will be added as a extra record into the target table with the key generation labeling it as 101, and on top of that this will be flagged as a new record. So you'll have the old record as well as you'll have the new record, even though you have a primary key column specified on that. So the table will save the history of your data using the history preserving transformation. All right. So I'll share this notes with you. So just look at this now, right now. So this is history preserving transformation, and this is the design of the job that we will be using here. So the prerequisites that we need to have for a history preserving transformation to happen on the target table is you should have these below columns created on the target table. So serial surrogate key, valid from, valid to, and column flag. So this is very simple. If you are good at the database, then you can create a table like target customer, like customer one, and you can append the table with the new fields. You can do that enhancement. So if you are good at the database level, you can just write a script saying that create table target customer like customer 1 and add extra columns like surrogate key, valid from, valid to, and column flag to that target table if you are good at SQL. I admit I am bad at SQL, so what I will do is I'll simply create a job. Okay, so lots of internet, so it loses the connection. Just give me a second, I have to restart this one. Yeah, the simplest way of doing it is create a job in the BODS and do a one-to-one mapping and execute the job. The entire data is loaded into the target table. Don't send. Okay. Okay, the simplest way is create a job underscore test, create a data flow. Now, if you want to add, for example, let us do that on the orders table. So if you want to add these extra columns to this one, make it as a source, use the table and call this as drgt underscore orders and save it in the target data store. Use a query transformation, connect it from source to target, go to the query transformation, create these 4 new output columns. One is s underscore key, which is an integer. It is good. The second one is valid from. This is a date column. The third one is valid to. This is also a date column, and the last one is the column flag. Var1. Right. So now we have all these 4 columns. So just let us populate this with the null values, empty spaces. Or I think for the job, we have a requirement that this surrogate key should be a primary key. So yeah, just let me check. Yeah, the surrogate key should be a primary key. After that, you can write a simple statement saying that alter table customer or target customer, add primary key as yes key. You can just write the statement so that this particular column will be turned into a primary key. So what I do is now validate this job. So there are 2 cannot insert null value. Alright, so you cannot insert a null value into this one. What we can do is like try to populate this with some of the other values. System date, valid from. So this we are trying to create a structure. You just keep this in mind. We are just trying to create a target table structure. Now the job is completed. Your table is ready. Target table with, oh sorry, oops. I forgot to add the remaining columns. Alright, so now you just execute the job. So your target table with whatever the required columns will be ready now with the surrogate key, valid from, valid to, and the column flag along with the columns that are present from your source. So next step that you need to do is select the table, right click and import table. Now you are making it as a permanent table, and now go to the database and just write a statement to truncate the target table and then convert the S key into a primary key. Okay, not recover. Connect. Go to the databases, go to your target database, go to new query, select the database, right click and go to new query, and just write a statement that is available here is truncate the table, truncate table. What is the table name? Just created trgt underscore orders. So go to the database. Okay, TEGT. Just let me cross check. Yeah, it's TEGT dot underscore orders. So now shift home. Okay, shift N and press F5 from your keyboard. It says command completed successfully. The table is truncated. So now what we will do is to cross check, select star from this particular table, F5. So there are no records. So if you check this count of star from this, there are 0 records. So the now the entire table is truncated. Now let me go and write one more command on the database saying that alter table add primary key as SKey. Right. So I think the column name that we have here is yes underscore key. Yeah, s underscore key. So now I'll try to use the same. S underscore key, F5, okay, could not create constraints. See the previous error. Already has a primary key defined on it. Okay, the table already has, oops. Okay, so the error that is saying that it is already having the order ID as a primary key, so you cannot create this as an extra primary key on top of that. So this is how you create a permanent table with this. So now let me import these tables that I have already used. Customers 1 and the second one is target customers, and let us build the job with that. Okay, so let me create a new job underscore okay, I created a job underscore history preserving. Then I'll create a data flow and call this as df underscore hp. Now I have the customers 1 table and I have the target table. Now if you look at the structure, only the surrogate key should be the primary key. That is the reason why it was throwing an error. So it should be the primary key. Only one key column should be the primary key column, and remaining everything should be normal. And right, so this is the table structure. So first let me build the job between these two. So if you look at the target table structure, you have surrogate key, then you have valid from, valid to, and the column flags, which we have created as extra columns, the same way which we have done. I did this earlier. And if you look at your source, this is the source structure. You have customer data, here. You don't have valid from, valid to, and a column flag. So you need to first add a query transformation, and in this query transformation you need to add one column which is valid from. Okay, I'll show it to you. Okay, the query transformation is used to add the new column valid from, and populate that with the system date. Okay, so now I'm adding a new extra column here. Take all the data that is coming from the source, now create a new output column and call it as valid underscore from, and it is a date type, and populate that with system date function. Okay, system date function. So this valid from is populated with the system date value, and the second one is, just go back. Next one is we use the table comparison transformation. So before you perform any history preserving transformation, you have to perform a table comparison transformation. So that is the combination. Guys, you are following, right? You can hear me and everything is good. We are not lost with the connection. Please confirm. You guys, can you hear me? Yeah, good. So this is how we build the job. So before you perform any history preserving transformation, the table comparison should happen, and I'll explain you what is table comparison and what is history preserving and what is the key generation. So table comparison, first let us look at the table comparison. Table comparison compares the source table data with the target table data, and it tries to identify the differences between that. So it does the comparison in three methods. One is row by row. So the first row of this table is compared with all the rows. The second row of the table is compared with all the rows. And again, if you feel that is going to hit the performance because you have huge volume of data on your source and on your target table, then eliminate that practice and do image by image comparison. And it takes the entire image, the screenshot of the data that is present in the source table, and it tries to compare that image with the screenshot of the data that is present on the target table. So image to image comparison is done, and wherever it identifies the change in the data, that particular record is either inserted or updated or deleted. So this table comparison, so look at the definition of table comparison. Compares two data sets and produces the difference between them as a data set with rows flagged as insert, update or delete. So it does a comparison between the source table and target table, and it tries to identify the difference between these two tables, and it tries to create the data sets. So if the records that are present in the source are not present in the target, it generates a new data set with the opcode flagged as insert on that. So if the same data is present but there are some changes on the data, it pushes the data as an update. And the data that is present in the target table which is not present in the source table, or if you want, I mean, it does a comparison, and that particular selective deletion should happen. So it pushes that particular data with the delete opcode. So this is what the definition of table comparison says. Compares two tables data sets and produces the difference between them as a data set with rows flagged as insert, update or delete. So just don't get confused with the map operation, map CDC and table comparison. If you see, all the three does separate tasks. So map operation, it used to convert between the opcodes Map CDC, it takes the opcodes from the database and works on that. Table comparison compares two tables and it tries to push you it tries to push the differences between these two tables with the new opcodes. So do not get confused. This is one tricky interview question that people will try to ask and enjoy the answers. So do not get confused, because all these three transformations work with the opcodes. All these three transformations does a similar sort of activity, but there is a lot of difference. Map operation, it allows you to do a conversion between the opcodes. Map CDC, it takes the opcodes from the database and works on top of that. And table comparison, it compares two different tables and it tries to generate the opcode. So now let us see how the table comparison works. So I connected this query transformation with the table comparison. Open the table comparison, and you don't have anything on the schema out. All you have is in the schema in. So now this is your schema in, the table, the source table, and here you have to choose which is your target table. So for that, click on this drop down here button, double click, and this is my target table. So this is my target underscore customer is my target table. If you just go back, this is my target table on which I want to do a comparison with the source using the table comparison. So once you select the target table, generated key column, you can select any key column or you can keep it vacant. So you can just select the surrogate key, and I think you can leave that vacant as well. Just let me cross check. Because these sort of transformations you generally don't use within your day-to-day activities. This is like a special task that you perform, so I just leave it as empty. And because we are not even generating any values into the surrogate key now, so we will be doing that in the key generation, so I'm leaving that empty. And now if you know that input can contain duplicate data, so you can check this box saying that you allow the bad data coming into the target table, because now if you see the mode of operation that we are trying to do here is compare between the tables. So if a record is compared, means if the source is having a duplicate customer number 1000 and 1000, the same data is present twice. This comparison happens twice on the target table. So if you want to allow such sort of comparisons, you can check this box saying that input contains duplicate keys or detect deleted rows from comparison table. So if you want to identify the deleted rows after the comparison is done, you can check on this box. It will give you the statistics save. And now the comparison methods, as I told you, there are three types of comparison methods. So if you have less number of records on your source and target tables, it is always advised to go for a row by row selection, because it takes the first row of the source and compares that with all the rows of the target. For example, you have 1000 rows in your source and 1000 rows in your target, so 1000 into 1000 iterations happen between your cache memory, so that is row by row. But just in case, if you have huge volume of data, when you want to do a comparison, go by cached comparison. So what this cached comparison does is, it takes a screenshot of your entire data from the source table and the target table. It saves that in the cache memory and it does a comparison on the data. So it compares the source cache image with the target cache image and it tries to identify the differences. Third one is the sorted input column. So this first does a sort on the data and then it does a comparison, because rather than doing a comparison on the junk data, for example, let us assume that I am doing a sort on a particular column like shipwire. So first what I'll do for shipwire 1, I'll do an entire comparison, then I'll go to shipwire 2, I'll do an entire comparison, and I'll go to shipwire 3 and I do an entire comparison, because this is a quick comparison that happens on the sorted input of the source data. So now input primary key columns, the columns on which you don't want to do a table comparison, drag and drop them here, and the columns on which you want to do a table comparison, okay, I just want to do it till country, drag and drop here. So what it does is when it does a table comparison, it eliminates customer ID from the comparison and it takes all the remaining columns from the source and compares that with the target table, which is trgt underscore customer. So this is how the table comparison works. You don't have anything initially in the schema out. The moment you select the table from the drop down here, so this output of the table comparison is always the target table structure. So this is one certification point of question and also an interview point of question. So they simply ask, they're doing a comparison between your source table and target table. So now, what is the output of your target table? What is the output of your table comparison? The answer should be the output of the table comparison is exactly the same structure of the target table, because you are trying to do a comparison on the source and the target, and you are trying to reveal the target structure outside using the table comparison. Next, history preserving. So the prerequisite for history preserving transformation is the table comparison should happen before the history preserving, because without comparing the data, you cannot save the history of the data. So keep this in mind. Without doing a comparison on the data, you cannot preserve the history of the data. So history preserving requires a table comparison done earlier. So now let us open the history preserving transformation, and this is a very simple transformation. Your schema in and schema out is already defined, because the schema out is always the target table structure, and here the schema in is also the target table structure. So now this is what you need to select here. The compare column list, the table comparisons that you have selected from, the columns that you have selected from your table comparison. You select those columns, drag and drop them in the compare column list. Valid from, you select the valid from. Valid to, you select valid to. And the valid to date value will with the new record. So you can either take the last date of the computer, which is 9012/31, or you can take any value, any date column here. So it says that Rakesh is moving from Bangalore to Hyderabad. So again, his data is changing from 3rd of 01. So March 1st, Rakesh will be moving back to Hyderabad. So I want to save his Bangalore transactions as well as the Hyderabad transaction. So we have a question here. Yeah, we don't compare the customer. All right. Yeah, that's good. Good catch, Rishabh. You can delete that. Thank you. All right. So now this is the date you want to choose, so you can select this one. And old record, for the old record, use valid from date of a new record, or use one day before the valid from date. So you can choose any of the dates, date from which the new record is changed, or one day before that date based on your business requirement. You can select that. And next one is column flag. So I told you this column flag is an extra column that we just created on the target table. So this will have the value as Y for the new record and reset value as no. Okay, and you have an option preserve delete rows as updated rows. So you can preserve the deleted rows from the target table. So this is what you do. There is nothing that you do in the schema in and schema out. You have the history preserving transformation tab here. So on the date columns, you need to select the from date and the to date, because history is always compared with the dates. You have a from date and you have a to date on which the history of the data is calculated or preserved. The second one is the new record. So you can either leave it as a default date, or you can select a date if you know the date. And you can also choose this radio button, like if the old record should have the same date value as that of the new record, or one day prior to that. and the column flag, the column which says that this is a new record, this is an old record, you can select this one here, and preserve, you can do this checkbox. And also one more thing, for the performance point of view, you can check this as a separate process, because if there is huge volume of data, once these comparisons are done, so this might hit the performance of this one, so you can run this table comparison as a separate process. So now history preserving is done. Connect that with the key generation. So what a key generation does, generates artificial keys in a table starting after the maximum existing values in the table. So this is a twisted definition, but in simple what I can say is, if your source table is having 100 records, this one generates a key value with the value coming as 101, 102 and so on. So the maximum existing key value is 100 and it generates a new artificial key value which is 101. So that's a simple thing. Open this one, and the table on which you are trying to do is the target table, target customers. Click on OK, and automatically chooses the surrogate key, and the increment value of the surrogate key is 1. Now this is done, connected with your target table. Save this job, job is completed, validate, there are no errors. So first go to the database and try to run this statement, truncate table trgt underscore customers. Okay, so let me take this table from here, trgt. Let me just check if this customers or customer. It is customer. So F5, the command is executed successfully. So select count of star from the target customers. Select the table, drag and drop it here. F5. Oops. Okay, so we have 0 records here. And now, next thing what I need to do is I want to write a simple statement. Okay. Right, so I want to write a simple statement here which does a conversion. Update statement. I want to write this update statement on my source table. So I go to the database, just go to the source database, which is Northwind. I think it is Northwind, right? So yeah, it is Northwind database, our source. So go to Northwind. Yeah, we have the Northwind here. Select, right click, go for a new query, and write the statement saying that update customer 1 table, which is coming from my source. This is the customer 1 table. Okay, so set city is equal to BLR, where the customer is equal to ALFKI. So now let us have a look at the data. So the city is already BLR. So now let me make it to Chennai. Okay, so what I am trying to do, this is the source data. So you look at this table name, this is customer 1, this is our source data. So the customer city is Bangalore, and I am trying to update this customer city to Chennai from Bangalore. Okay, so I am trying to update this, or you can see the data at the database level as well. So write a simple select statement, select star from customer 1, F5. So I see the data here. This is customer ID is equal to ALFKI, and the customer city is equal to Bangalore. And now I write an update statement saying that update customer city is equal to Chennai, where the customer ID is equal to ALFKI. So press F5, one row is affected. Now you do an F5 here, and it says it is Chennai. So now let us run this job first. Okay, now because I truncated this table, there is second, it should not be there. Okay, just let me run this job first. Job is completed successfully, and this table has total 93 records. So now let me truncate this table first. F5, then select count of star from the target customer. There are 0 records in this one. Why, what happened? Okay, 1 second. Yeah, I was doing it in the wrong database. So actually I should do that on the source Northern database, but I was trying to do that on the target database, so that is the reason why it is not affecting. So now we have 0 records here, and first let us do an initial run. Now initial run, what it will do is whatever the records that are present in the source are pushed into the target table. So now if you see, the customers has 91 records coming in from the source, and these records are pushed as is. The same 91 record count is present on the target table. Now go to the database and see, if you see the data in the target table, the customer city is Chennai for customer ID ALFKI. So now go to the database and make it as Delhi, okay, where customer ID is equal to ALFKI. Press F5, one row is affected. You want to see the data, you can see this from pressing F5. The city is updated to Delhi. Now we have to save the history of the data, so that is the reason why we are building this job. So the old record says Chennai, and this new record should say it is Delhi, and also you should be able to see the old record. So I'm now doing not doing any changes to the data, and just executing the job. Right, the job is successfully completed. Go to the data flow and see the data. Right, ALFKI Chennai is present, and that is N because that is the old record. Go to the bottom of the table, you see 92 record. What we have seen from the source is only 91 records coming in from the source, but now you have 92, 92nd record added, and again ALFKI, and just let me filter on this one so that we can just see the 2 records. Okay, right, so now you see the first record is ALFKI, which city is Chennai, and second record again ALFKI, which is Delhi. So now we are saving the history of the data, and the old record is flagged to N and the new record is flagged to Y. So this is how you preserve the history of your customers. Okay, this is type 3 CDC. So this is the type 3 change data capture, where you change only one transaction of one past transaction of your customer, like one history, the recent history, you save it. And type 2 is like you change unending history, or the entire history of the customers or entire history of the data. And type 1 is you do not change the, you do not save the history, you just override the history with the new records. Whatever the change record, whatever the old record that is present in your target table, you override that. Type 2 is you save a lot of history, and type 3 is you save only the past history. And this history preserving transformation is used to perform this change in the data and the save in the data, like where both the type Chennai and Delhi, both these customers are saved. Okay, so I'll share this notes with Prakash, and Prakash will be sending email to you with those notes. It has good screenshots. I created them. So you can see the data with the screenshots. It is very good one that even tells you how to create the job and the navigation for that, everything. So you can go through this one. And this is how we use history preserving, table comparison, key generation, and a query transformation as a combination transformations and perform a task. Okay, so this is a standard tool sort of thing that you are generating, and if you want to do any changes on the data, you can utilize this and you can do changes. So is this clear? Any questions on this before we go to the next transformation? Yeah. Yeah, Jay, any question from your end?
Right now, no. I think it's a slowly changing dimension type 2, right? We discussed about.
Sorry?
This is a SCD2, right? Slowly changing dimension.
Yeah, SCD2. Yeah, 2. This is type 3, I guess. I mean, I'm bad at SQL database things, so forgive me if
It's
I
a data
didn't.
warehouse concept. It's a warehouse concept, actually.
Yeah,
It's
it is a warehouse concept.
I think SC2.
Okay, I mean, I asked one of my colleagues who is the database expert. I went to him and asked him, boss, tell me what is type 1, type 2, and type 3. So he told me that. I just remember that thing, because even if I read that thing, I don't think I will remember. So maybe that is a small change between type 2 and type 3. So I think
yeah. In type 3, like just they will change only the location, like not anything else, the effective dates and all. Suppose you move, they'll maintain only one record, not like multiple records.
Yeah, exactly. Only one record is saved.
But they add another new variable that is the current location, like that.
Yeah, yeah. Guys, okay, just Google it and try to check if I might be wrong, because I'm very bad at the database levels or warehouse levels, because that is one thing that I fight in my interviews, saying that do not ask me any questions on the database level, because I'm not a guy from that side. And when I talk about data services and tell all these CDCs, they get confused, like, hey, you're saying all these things, but why don't you accept that you are good at database? Because I say, I don't know what is that. I can say that related to BODs, but I don't know what is that. Okay, so just Google about this SCDs type 1, type 2, and type 3, and try to correlate that with the class. That is what all I can say. And any more questions, Jay?
No, I think once I practice, then maybe I will get more. Right now I don't have actual database, so that's why I'm creating database. Like once I'm done with
you
that,
can download these databases from internet, Northwind.
Yeah, I did that, but it's giving an error. Actually, I'm trying to, export the data.
So, yeah, try to download the exact version, which is whichever is the version that is present on your database. Try to download, if it is 2008, try to download 2008 and attach to that list of databases. And the second thing is, like, also see the version, it is R1 or R2, there is a patch, I guess, so you have to.
Yeah, it's throwing an error, like, data type is mismatching like that when I'm trying to export the data from Access to SQL Server. So,
okay.
So let me create like another way, I think, by using some other.
Yeah, okay. All right, so there's one more request. We need to call it a day, or if not, people will hit me tomorrow.
Yeah, actually, if you do all these things in one day, like, it's a little bit confusing process.
Yeah, I accept that, but this is how I do a training, because I did almost like 50 batches so far, 50 plus batches, and all these things go in one day. So all these things go in one day. But Prakash told me in the beginning, like, no, you should not complete that within 10 days, because this program is planned to complete within 10 days. And he said, no, you're not going to do that. So that's why I said, okay, I'll try to go over a slow phase, but this is how it goes. And yeah, people are there who went through this training and who are working as like leads, architects, and managers, whatever the designation they are. But yeah, we will go ahead on a little slow pace, because that is what is agreed between me and Prakash from the day one. So we will take it a little slow. So I'll call it a day, and yeah, tomorrow we will have a class, and we'll have a class at the same time, and tomorrow also we will have an extended class. And let me tell you the reason why I'm out of Bangalore, because we are expecting a new guest into our family, expecting a baby. Any movement?
Congrats.
Yeah, thank you. So that is the reason why I flew back to Guntur. So right now I'm in my in-laws place along with my wife, taking care of my wife. Thanks, Rishabh. So I'm not sure like when exactly the delivery might happen. So if something is there and I have to be at hospital, I will ask Prakash to log in at the morning call, and he will update you guys on that. If not, there is a class. If there is no class, then Prakash will give you an update on that. Or Rishabh, I'll send you an email on top of this. Okay?
Okay.
If not, by default, we are having a class at 7 a.m. IST tomorrow, and that will be an extended class because I want to complete the transformations, the remaining transformations, as well as the quality transformation that we'll be looking at, and also the data insight transformation, data insight tool. So that is what we'll be looking tomorrow. So be prepared tomorrow. Have your boost or everything or energy drinks next to you. We'll complete all these things. Okay.
Yeah.
All right, guys. Thanks for your time, and have a good night and good day ahead. Enjoy.
Yeah. Thank you. You too. Bye now.
The organizer has ended